Hi everyone, welcome back to next session. Today we are going to discuss about another problem on Chinese remainder theorem. Before entering that, I would like to recall the working rule for this theorem. So first one, using the given divisor, is supposed to find out the n value. That is, n is nothing but multiplying the modulo values m1 into m2 into m3 and so on mk. Suppose if you are having only two congruences, we can multiply m1, m2, m3. 4 means m1, m2, m3, m4. Likewise, we can multiply all the divisors. Through that, we can find out the n value. And ni is equal to n by mi. This formula is very important. Suppose if you are having three congruences, we can replace I is equal to 1, 2, 3. Likewise, we can find out n1, n2, n3. Right? So look at the first step. We have to find out the solutions of y1, y2, y3 and so on yk, where ni, yi is congruent to 1 mod mi, where I running from 1 to k. Right? So step 2, the general solution of mod n for finding x value is equal to a1 n1 y1 plus a2 into n2 into y2 and so on ak nk yk. So here this a1 a2 ak are nothing but the remainder of the given problem. So we need n1 y1 n2 y2. So substituting I is equal to 1 2 3 in this equation, we could easily find out what is n1 n2 n3, right? But we don't know how to find out y1 y2 and so on yk. In such a case, I'm going to apply the trial and error method. So these are all the algorithm for solving the problem by using Chinese remainder theorem. Let us take the problems. Solve the system of congruences. X is congruent to 3 mod 7, so x is congruent to 4 mod 9 and x is congruent to 8 mod 11. So solution, you just write the given system of congruences as it is and write the a1, a2, a3 values. As I said earlier, the remainder of the given problem is taken as a1, a2, a3. And look at the modular value. First modular value taken as m1 equal to 7, second m2 is equal to 9, third modular value m3 is equal to 11. As per the Chinese remainder theorem, these modular values must be pairwise relatively primes. So just find out the GCD of any two values, m1 with m2, m2 with m3 or m1 with m3, their GCD must be 1, right? That's what I have given here. Now I'm going to find out n value with the help of this one. So just multiply m1 into m2 into m3, you will get n values. Multiply m1 with m2 and m3. Through that we can find out n values. So what is n value here? 693. Now the general formula for ni is equal to n by mi. So here replace n equal to 1. That is, we'll get n by m1. So just cancelling the 7 and 7, we will get n1 value is 91. Similarly, n2 value getting 77, n3 value getting 63. Why we needed to find out three values, especially why we needed to find out three values? Because the given problem containing three congruences. That is the reason I am finding n1, n2, n3 with the proper substitution in the given equation. So now I am getting a1, a2, a3 value and n1, n2, n3 value. What is the rest of the things? We need to find out y1, y2, y3 value. For that, we need to satisfying this condition. So what is that condition? n1 into y1 is congruent to 1 mod m1. So here I am going to replace n1 value is equal to 99 and the first divisor m1 value is equal to 7 and the remainder is 1, right? So this is nothing but this result extracted from the Chinese remainder theorem. Now what is the suitable number I supposed to replace in place of y1 value and multiply that value with 99, right? Finally we are getting some biggest number. That number supposed to divisible by 7, but the remainder must be what? 1. So we supposed to replace the value accordingly, right? For example, replace y1 is equal to 1, you will get 99 as the value. Divide that 99 by 7, Suppose if we are getting 1 is the remainder, we can declare this 1 is the solution of y1. If we are not getting, we can move for another value. Fortunately, the first value itself given the 1 as the remainder. Therefore, we can conclude 1 is the solution for y1. Similarly, go for the second one. N2 y2 is congruent to 1 mod m2. So we know the value for n2 is 77, right? Now we are going to replace y2 value. Just try to replace y2 is equal to 1. We can't get 1 is the remainder. Therefore, I am replacing y2 is equal to 2. Multiply 77 with 2, you will get 154 is the answer. Divide that 154 with 154 by 9, you will get remainder is 1, right? Therefore, y2 is equal to 2 is the solution. And n3 y3, n3 value is equal to 63, right? M3 value is 11. But by using trial and error method, substituting 1, 2, 3 value, whatever values replacing up to 6, we won't get remainder as 1. So therefore, 7 is the suitable number for this case. It's after all a trial and error basics. You just multiply 63 with 7, you will get 441 is the answer. Now divide that 441 by 11, you will get 1 is the remainder. Therefore, the value for y3 is 7. Now we are getting y1, y2, y3 value. Already we are having a1, a2, a3 value from the problem. Through the general formula, we are getting n1, n2, n3 value. Into mod n is the formula. N value is 693. Replace the respective value in the formula. What will come? a1 I replaced to 3, n1 I replaced to 99, and y1 1. Similarly, a2, n2, y2, a3, n3, y3 into mod n, that is 693. Add all the values, you will get 697 plus 616 plus 3528. Add all the values, you will get 4441 is the value. It's a hugest number. You just divide that number by 693, you will get 283 is the remainder. So we can declare this is the solution for the given problem, right? Even if you are felt this is difficult to divide, you can't divide these two number separately by 693. You can divide this number by 693, you will get remaining number, that then you can add that number with this. So that is ultimate aim. After getting this all addition, you have to divide that number by 693. So whatever the number is existing, that is our final answer. So here 683 is there, your divisor is 493, we can't divide it, no. So therefore we can declare this is the solution for the given problem. So how to check whether the given problem is correct or not? If you are having idea, you just replace this value in the given problem wherever x is there, then divide, you will get the exact answer. So 283 is the unique solution for the given problem. For example, 283 we are getting, right? So in place of x value, you replace 283, divide the 283 by 9, the remainder must be 4. Similarly, here replace x is equal to 283, divide the 283 by 7, remainder must be 3. Here replace x is equal to 283, divide by 11, it must be given the remainder as 8, otherwise answer is wrong. So this is the way to check whether our answer is correct or not. Thank you.